8 weeks now, and it's beautiful. I grew up in Michigan, so the cold weather doesn't bother me at all. And it's really, it's terrific to be welcomed here, and just walking around the room, getting to see all the activities going on, and hearing about 10,000 people as being part of that makers community is very exciting. So this is a great place for me to be. So today I want to just help connect those makers, the makers community here in Connecticut, with some of the things I've been involved with over my career, and especially recently coming here to Connecticut. So with that, give you a little background on UTC. So I learned a little bit that not everybody might know about United Technologies, but it's a $56 billion company headquartered right here in Connecticut. The businesses that I'm associated with is United Technologies Research Center, and there we're standing up an additive manufacturing center of excellence, so very much an industrial makerspace. With that, the $56 billion of sales that comes into Connecticut here is divided up between both military, aerospace applications, and building sciences, and those parts of the businesses that make up. So what's interesting, what attracted me to come to UTC, I came up, as Deborah mentioned, and I started with McDonnell Douglas working on defense aircraft like the F-15, C-17. When Boeing acquired McDonnell Douglas, I got more into the commercial side. My first 15 years I really spent on the shop floor. So I sort of shop floor rat. I started off with non-destructive testing, where I was inspecting new technologies like composites back in the 80s and superplastic forming, diffusion bonded, and really got into technologies like high-speed machining. But towards the middle part of my career, I was out in the assembly area, and everything we were doing is pretty much manual. And my last 7 years, I got to lead a team that focused on assembly automation. And today, aircraft like the 787 are built and highly automated. I got to see that part of that go on. So coming here to United Technologies is a great opportunity to be involved with all these different business units. It's a more diverse background than what I've had the opportunity to work on in my career, and I think it gives us a greater launching pad to bring additive manufacturing into the mainstream. So with that, the businesses that we're talking about, the aerospace systems business, located in Windsor Locks here. If you haven't been up there, I had a chance to visit that factory. It's amazing how large that is, and then how much work they're doing in additive and trying to bring that into production. United Technologies, the climate control security business. A lot of people relate that with the Carrier product line for your home HVAC systems, but there's thousands of product lines that we have the opportunity to introduce additive manufacturing into. That's really an exciting part of the CCS business. Pratt & Whitney, the jet engine business. This is where most of the discussion around metal additive manufacturing has been over the last 5 years. It started with GE, and a lot has been publicized about their fuel nozzle. But the background that's going across Pratt & Whitney, the science behind the additive technologies there, we're going to really help accelerate where they are with metal additive. And then Otis Elevators. I didn't know a thing about elevators when I came in. And so they actually have a whole textbook on how to design elevators that I'm going through right now, trying to educate myself. But Otis Elevators is also located here in Farmington, and I had a chance to visit with them and talk about their different product needs and the different applications for additive. So across the board, there's plenty of opportunities for additive within UTC, and we're going to help stand that up. So a little bit more about the businesses. I joined UTRC. It has a number of different focus areas, but number one up on the board here is advanced manufacturing. So that's really where I've spent and focused my entire 30-year career has been in the manufacturing area, and then in the last 15 years really has been on advanced manufacturing or manufacturing technology development. But with additive, there's so many applications of additive with these other spaces, specifically with aerodynamics. That was a lot of where additive got started in looking at wind tunnel models and things like that. The early days, about 30 years ago, we were doing a lot of selective laser or SOA type models for wind tunnels. The combustion, that's been a big piece of additive. Anytime you can design for functionality and there's internal flows or channels into parts, it's ideal for additive. You can really change the way the product is designed and how it functions. So those are great opportunities with combustion. New material spaces are turning up all over with additive. When I first got involved with metal additive at Boeing in around 2005 or 6, there were only two materials that you could do with, two metal materials that you could do with additive. Today, there's more than a dozen, and I see on the horizon there's 4 times that many in development. So that space is expanding rapidly. The powder industry has grown to, it's over $100 million of making metal powders for additive, and it's expected to get close to $1 billion in the next 5 to 7 years. So great spaces in additive. And with each one of these, there's opportunities for additive to make an impact. So coming up to the maker space, and what everyone here is looking to talk about, is how do you do these collaborations? So in the last 10, 15 years, the way that companies do their research and development has changed quite a bit. They're not as much internally focused as they used to be. They're looking to get out, find ways to collaborate with other people in the industry, whether it's competitors or non-competitors. There's opportunities both ways. How do we start to engage the universities, the national labs? There's tremendous resources there. So with any company, you know, there's a lot of smart people on board. They just don't all work for UTC or whatever the name is. But, so how do you go out and connect with those people? That's what we're trying to do here. So UTRC is a major player in making that happen within the UTC family. So we connect with our business units. We connect with others in the industries. We're finding ways to engage with suppliers. And then how do we engage with these maker spaces? That's of interest to me, especially when there's 10,000 people out there in just Connecticut coming together. They're going to solve a problem. I hope it's one of our problems. So more along collaboration. So UTC has been a major player in participating in a new initiative that was launched back in 2012 by the federal government called Manufacturing USA. This is the government's highest commitment to manufacturing that's going on. Each one of these institutes, of which there's 14 institutes, is funded with around $70 million of federal funds. That is matched by an equal 1-to-1, or in most cases more, of federal, of industry and state funding. So this is over $1 billion of investment going into these manufacturing areas. And I'll tell you a little bit about each one. So American Makes, that was the first national network for manufacturing innovation center that was launched. It was launched with about $50 million, and it was funded by all these different federal agencies along the bottom here. It was launched in Youngstown, Ohio, and it's really one of the original additive manufacturing development labs that's accessible to everybody. Each one of these manufacturing institutes has a mandate for workforce development and education. So those of you that are educators here, those of you that are in the maker space, you have the opportunity to engage these big, huge investments in manufacturing and find out how to take advantage of that workforce development and education. ARM is the Robotics Institute. that's led by Carnegie Mellon out of Pittsburgh, but it has a number of regional centers that engage. Every one of these has Waste Engage or a location in the Northeast. LIFT is Lightweight Metals for Tomorrow Institute. That's out of Detroit, Michigan, and it's really focused on lightweight metals for automotive. Then you have Army, that's regenerative manufacturing, so it's more of a biofab. That's out of New Hampshire. Actually, Dean came in from First Robotics, is leading that one. So that's a great connection for those of you that are involved with First. AFOA is the Advanced Fiber Institute. That's led up by MIT. They're doing smart fabrics. So they've already launched smart backpacks so to keep people connected through their clothing, through articles like that. Smart Manufacturing Institute. So I see there was some stuff here as far as controls and that. Smart Manufacturing Institute is really about that industrial Internet of Things that's going on. DMDII here over in the upper right-hand corner is the Digital Manufacturing and Design Innovation Institute. It's led up out of Chicago area, and they're working with like groups like the SO and Mastercam on that digital model, the programming, and all that type of stuff that comes to helping us manufacture parts with that digital background. Rapid is a process intensification industry. It's led up out of New York City, and it's focused a lot on the chemical industry and in the production processes that require a lot of energy. Remade is out of Rochester, New York. That's looking at recycling, reuse, sustainable manufacturing. Photonics, that's another one led out of Rochester. Focused on some of the most advanced electrical photonics type systems that we're going to use here in the future. Netflix, that's flexible electronics, that's up out of San Jose, California. IACME is the Composite Institute that I had the privilege to lead for a year out of Knoxville, Tennessee. And I'll talk a little bit more about that model in a minute. Nimble is a biofab out of Delaware, University of Delaware. And then Power America was one of the initial ones in power electronics out of North Carolina State University in Raleigh. So these institutes are heavily funded. They have large engagement. These are industrial collaboration institutes. It's bringing together government labs, industry, educational institutes to develop the next steps for manufacturing in the next 5 to 10 years, I would say. So let me come back to the Composite Institute because it really led to my coming up here to take on the Additive Manufacturing Center of Excellence for UTC. So IACME was the 5th of these institutes that was launched. It came out with a different model. It came out with a model that said we're going to have physical sites. We're going to bring industry, academia, and government together at these physical sites and have these industrial collaboration spaces or industrial maker spaces. So IACME has sites in Detroit, Michigan area, and Lafayette, Indiana, and Knoxville, Tennessee, and Dayton, Ohio, and boy, I should know that. Well, anyway, but they created these industrial collaboration spaces. They're very much like the maker spaces that get talked about, but on a larger scale. So when I was approached by UTC, and they went over there at the Manufacturing Center of Excellence with me, this is very much a center, just like what we were creating at IACME, that basically provides state-of-the-art facilities. UTC is investing over $75 million over the next 5 years in this facility. And it's a place where we are going to locate some of the top talent, equipment, and tools and make it available for our businesses to come together there and work on their next generation customer applications. So the way that we're organized is we sit there and we support the various business units that I talked about, whether it's United Technologies, Aerospace Systems, Dods, CCS, or Pratt Whitney. And then we provide these tools along design, modeling, simulation. We see some of that going on here. The process sensing, I see some of the controls technologies that's going on. Material informatics and analytics, that's a critical piece of what we're talking about. Deborah mentioned in my bio that I have a mathematics background. I just got that last December. I went out and earned that mathematics degree because there's so much of that coming into the manufacturing space now that I wanted to continue to build on my just foundational background to take manufacturing to another level. And then the data certification. With anytime we're putting out product, we have a certain level of liability, data certification requirements, and we're going to be responsible for that. So the way that we look at this is we have a core technology team. These are some of the top scientists, PhDs at UTRC that are working with us to enhance these organizational capabilities in those areas. And then we have a deployment team, people like myself that have a long history in manufacturing and know how to scale up, introduce automation, things like that. And we're going to be rolling that out. So we're going to provide the businesses with the recipe for the parts, the equipment, the quality system, and everything for them to be able to stand up and productionize additive manufacturing. Like I said, my whole objective, the opportunity that UTC presented to me, was really about making additive manufacturing mainstream. So when I think about setting up a manufacturing endeavor like what we're talking about, I want to look at an entire production system. And this is something that maybe you can take and incorporate into some of the maker spaces, different elements of what we're talking about here. Let me start in the lower right-hand corner, and I'll build up to that. So with data input and sensors, that's become more and more critical. As we move from analog to digital sensing, you can have both types, but we're going to get away from a lot of the Six Sigma data collection that we used to do, where we do an individual measurement, we have a point, we plot our stuff. We're going to start getting all our signals through these data, through these sensors, digital or analog, and we're going to find ways to process that. But the next level is in this data management and analysis. So what we're looking for is not to create big databases, but you're going to have to be able to process this data out on the edge of your network, out as close to your manufacturing process as you can. If not, build it into your manufacturing process. That's ideal, the whole point of closed loop controls. The equipment and hardware. Today, almost all pieces of equipment that we buy are running some type of CNC or PLC controls, digital controls. They're driven by digital technology. And then the equipment can all be connected to the network, very simply. If it doesn't already come capable to the network, there are cards that you can put in to a machine control and connect up to the network. Processes. This is where I start thinking about how do we redesign the process that takes place within a machine tool or inside a welding booth or whatever it might be, to take advantage of all these different technologies here that we have, from sensors, from digital design. Are we really taking advantage of all the information that comes to us from the digital definition and building that into the process? Value stream, this is just about how efficient you are in stitching together all your different processes. There's a lot of tools out there that help you simulate the factory floor and your supply chain that you can begin to use. Modeling and simulation, that's typically talked about as a separate issue, and it's been the domain of engineers and scientists. We're pulling that into the manufacturing space. And that's why I stitch on there the controls piece of it. Because we're going to be able to take modeling and simulation outputs and change the way that we either do our programming or feed it into the controls, and maybe modeling and simulation becomes our next programming tool to interface with machine controls. Networks, factory networks, to move into an old factory and try to wire that factory up for a network is very difficult and expensive. Now with all the different wireless technologies that you have, it's very easy to connect up a factory, old or new, and get all that equipment online. With the architecture, this is where really distributed network architecture is more critical than anything. You want to have the information out at the edge of the network as close to the machines as possible. We tend to have always thought about these large databases and trying to pull everything centralized. This is really a different approach, and you're going to do more computing out on the edge of the network. With the business processes, with any large company or small company, you have to find a way to take these, each one of these activities inside these boxes and turn it into something your business is going to value. So in the case of large companies, we have the opportunity to connect right into the ERP system so that we can capture the gains that we made from introducing some of these new technologies. Thinking more about than just the process, the machining process. There's all sorts of building sciences that you can get into. I mentioned about half of UTC's revenues come from their building businesses. But the infrastructure, one of the easiest places to start doing sensing and controls and that is with your compressed air systems, with your HVAC systems in your plants, and with your electrical distribution systems and things like that. You can save a lot of money. You'd be surprised at how inefficient factories get over time. As you move new machines in and mix them with old machines, there's opportunities here to improve your infrastructure. And then with manufacturing ecosystems, within any business, your competitors aren't staying still, your suppliers aren't staying still, your whole supply chain is going to have to continue to be reconstructed. And the biggest thing, and I think what this community here is doing is really addressing that people and culture. So I was fortunate enough in my career, people took an interest in what I was doing. I had no idea what I was actually capable of doing. I was very happy being in the production format. People pulled me up. They helped me realize potential that I didn't know I had. I think groups like Makerspaces can help people, kids, First Robotics, discover things that they didn't know were possible. So how do you empower people to be better than what they could ever imagine themselves as being? And I've been very fortunate that people recognize that. So, with that, I want to leave you with a couple of things to think about with maybe what more could Makerspaces be. These are four trends that I think are coming very fast in manufacturing. I don't think most manufacturers recognize that this is going to impact their businesses, but it's coming. So gaming technology, and especially multiplayer gaming, there's all sorts of opportunities for people, individuals to probably start businesses, get things launched. How do you develop manufacturing systems that take advantage of gaming? And this is just one example that I think about. So today I've already mentioned about Six Sigma and some of the quality initiatives that were from the 1990s. We have very good supplier networks as far as quality. We don't question that. What we look for now is we still see a lot of variation in what we get. We can start competing each of the suppliers against each other on who's contributing the most amount of variation through having some tools like variation analysis, variation simulation analysis tools that look at the CAD file and the dimensions and the tolerances. And then we have 3D measurement systems that can give you point clouds. We can mesh that together and we can start to evaluate who's really costing us the most amount of money and let the suppliers figure out how to address their issues and create that gaming environment. high performance computing, so modeling, simulation, and controls, when I mentioned that. When we're going to be bringing high performance computing into the manufacturing environment. Now, whether that's through the cloud or some other way, I don't know how that actually will materialize, but high performance computing is going to become a major factor in helping us analyze the amount of data that is generated on the shop floor and turning it into something useful. When I talk about computing out at the edge, this is going to be what makes that happen and make that valuable. So we have to be able to digest that amount of information within the takt times of our factory. So typically, people only think about takt time with regard to the physical activities and not the back office shops that support the factories. We need to bring the back office and those support functions into the same takt time to hit the levels of performance and efficiency that's going to take us to the next levels of productivity. I'm going to talk about manufacturing and app development over here in the lower left-hand corner. So, over my career, I've kept 3 books on my desk the whole time. One was a dictionary, the next one was a grammar, and then the third one was the machinery's handbook. And so, for any engineering student, I got out in the 80s, but we did a lot of our engineering based on tables and standard formulas and things like that. Machinery's handbook consists of well over 1,000 pages of these types of data tables and information. I'm wondering who's going to take the opportunity to create the maps that I could use on my phone on the shop floor and not have to go to those lookup tables. I think that's a tremendous opportunity for high school students and college students to really get into a business of their own. And then we already heard a little bit about Moore's Law, but there's something else with the industrial Internet of Things that's going on. Every device, so Metcalfe's law, this was really demonstrated, it's an empirical law that was demonstrated around telephones, the value of telephones, the value of fax machines, that it increases proportional to the number of devices squared on the network. So the more machine tools that we put on the network, the more welding stations we put on the network, the more value they're going to be. And there's a huge activity going on, and as I said, almost every piece of equipment you buy today, you can hook up onto your shop floor. And so this is really going to start to take off, and that's what the Smart Manufacturing Institute that I mentioned as part of Manufacturing USA is all about. So those are 4 trends that I see coming, and I think there are opportunities for maker spaces to incorporate into the things that they're doing. I'm very interested. I've already seen elements of each of these in some of the stations that I had the opportunity to walk around and see. So hopefully over the next 5 to 10 years that as you grow the maker community here in Connecticut, many of them will take advantage of these and be successful businesses. So thank you very much for welcoming me to Connecticut. I'm happy to be here.